Okay, to start with, I actually want you to look at that page 41, problem 41, and it says a point, 1 comma 2, and then it says a slope. But it doesn't just say the slope. It says y equals 3x minus 2. You need to know where the slope is. I hope this is a no-brainer. There's the slope. So now, if they have given you a point and they've given you a slope, what could you do with it? Point slope. And that's what you're supposed to do with it. In part A, you're supposed to do a line that's parallel to this, so that would have the same slope as this. And so you'd use the point 1 comma 2 and use the slope would be 3. But in part B, you would use 1 comma 2 and you would not use a slope of 3. In part B, it wants it to be perpendicular to this one. You don't use 3, then you use what? Negative 1/3. Now, is this point slope form? No, this is point slope form. Y minus y sub 1, and this is the y sub 1, equals m times x minus the x sub 1, and that's the x sub 1. There we go. There's your first answer for 41A. And then 41B is pretty much the same thing. Y minus the y sub 1 equals m times x minus the x sub 1. And then you stick in this point here and here. Then you stick in this slope, which is the negative reciprocal. And you put that in there. Okay, that's what you're supposed to be doing on those. Hopefully you did it already on your homework last night. But if you didn't understand it, a lot of people asked me about it. I figured it must have needed clarification because I had several people come in the morning and ask. All right, so anyway, that's some of last night's homework. Now, for 2 nights, we need to be good at factoring. That's why we made sure that you were good at factoring. Otherwise, you shouldn't stay. But if you can get good at factoring really quick, then I guess there's still hope for you. So if we're going to do this one, we need to get the x's all onto one side, and then we're going to factor it. So solving sometimes involves factoring. So right now, how do I get these 20x's to go over there? Subtract it. So everybody, please write this problem down. And then subtract 20x squared from both sides. And I know that's annoying for some people that this all disappears, but it just equals 0. And that's okay. So how do I write this jumble of 3 things? You put it in order from the biggest degree to the smallest degree. So what's the thing with the biggest degree? 15x to the third. What's the next biggest thing? Minus 20x squared. What's the smallest thing? Minus 35x. Now, it may not seem like I have solved it, and that's probably because I haven't. I haven't got x alone yet. To get x alone, I'm going to need to do the factoring thing I was telling you. So what do you see that's in all 3 terms that can come out? 5. And what else? X. You need to be able to do this at least. If I tell you 5x goes in, you've got to be able to do this part. (3x squared), and how do I check if I'm right? I go 5x times 3x squared, and I should make sure that it actually equals 15x to the third, and it does. And the next thing is, how do I get 5 to turn into negative 20? With a negative 4. And then I'll need an x. And the last thing is negative 7. Raise your hand if you factored that right. Good. Now, are we done factoring? No, got to factor it again. 5x, and then 2 sets of parentheses. Do you have a 3x and an x? That only makes sense. 3x and x would give you the 3x squared. And the last one there, to get the negative 7, what times what is going to make negative 7? There's really only 1 and 7, right? One of them has to be negative. And I don't know which one. So I'm just going to put in a 1 and a 7. And I'm just going to totally guess that this one's negative and this one's positive. And then I'm going to check. It's just guess and check. You just keep checking over and over again. That would come up to 10 minus 1 would be 9x. Is that what I wanted? So then I didn't do it right. So then I got to try again. In fact, it wasn't even close. So I'm going to try switching the 7 and the 1 around. And now just, again, randomly put in a negative and a plus and try to figure out if that works. Now, that's negative 7x and positive 3x. That makes negative 4x. That's what I wanted. So you double check it like that to make sure it comes out to what you want. Now I have factored it. I still don't have x equals yet. I still haven't got x alone, but I'm now really close. I hope you remember this kind of problem where you would get where an answer for whatever makes this 0, that's one of your answers. Whatever makes this 0, that's one of your answers. And whatever makes this 0, that's one of your answers. So I'm going to get 3 answers here. Easiest one, this one. What could I make x right there that would make that part 0? Negative 1. So that's one of my 3 answers. This is probably the second easiest one. 5 times what would make this whole thing here 0? 0. X equals 0 is the second root or solution or x-intercept. Those are all the same thing. And then the last one here is definitely kind of hard to do in your head. So what you do is you write 3x minus 7. I want it to equal 0. See, I'm making algebra out of my head. I know I want it to equal 0, so I write an equation. 3x equals 7, and then x equals 7/3. So if I actually put in a 7/3 here, to get out of the 3, I'll cancel the 3, and then I'll have 7 minus 7, and it'll equal 0, just like I wanted. All right, so 1 answer, 2 answers, 3 answers. Why is there 3 answers? Because there's 3 things that if I stick it into this equation, will make it equal, will make it work. Okay? And 0 is one of them. Think about this. If I put in a 0 here and here and here, everything will be 0, and it'll end up saying 0 equals 0, and that's right. It's what I wanted. So that's one of my solutions. All right, so I've got 3 solutions here. That involved a lot of things. That involved you knowing to get this 20x over to the other side. It involved you factoring. It involved you factoring again. And then it involved you knowing that each one of these things needed to equal 0. So that's a lot of review all at once. Are you following me? Do you remember this stuff? Okay. Good. And what we're mainly talking about today is quadratics. And a quadratic is anything that has x squared in it. Okay? So it could be just x squared. That is a quadratic. So ever seen this? Y equals x squared. You remember the graph is just like one of these little dealy bobs? You remember that? That's the simplest of all the quadratics. All you have to have is an x squared in it. Now, it can have other stuff, like if it can have an x squared and a 2x and a minus 3, for instance, and that's still a quadratic, as long as the biggest degree is 2. Then it's a quadratic. Okay. Here's another one that's a quadratic. X squared minus 4. That's a quadratic. It's got a squared in it. All right, so solving quadratics is trying to find what number will make the equation equal 0. Now, why do I want this whole thing to equal 0? I want this not to be a y. I want it to equal 0. Because do you remember when you graph these things? The answer is wherever it touches the x-intercepts. Do you remember that? That the answers are those spots here and here. And those are the spots, the x-intercept is where, fill in the blank. Y equals 0. Remember? The x-intercept is where y equals 0. That's why we set these things equal to 0. Because we want the x-intercepts. So we take the whole equation, put it on one side, and have 0 on the other side, and then we'll have this equation has to equal 0. All right, that's what we want to do in solving a quadratic. Now, you could solve them in several different ways. There are 4 methods of solving a quadratic. One way, factor it and use the ZPP. The quadratic equation must be equal to 0, not any other number. That's what we did here. Remember, we got this to equal 0 here, and then we factored it. That was factoring. That's the factoring way to solve it. All right, so go back to this one. Could I solve this by factoring? If it factors, yeah. Let's see if it factors. What does it factor? Come on, wake up. Does it factor? Yes, it does. X, what? Plus 2 and x minus 2. Now, I bet you can see the answer staring right at you. How do I make this equal to 0? How do I make this equal to 0? So my answers are x equals -2 and x equals +2. And if you think about it, how do I make it equal 0? I take these and I stick them in here. And if I stick in a -2 there, it will equal 0. Or if I stick in a +2, it will equal 0. Okay. So I'm solving a quadratic. I can do it by factoring. That's the way I just showed you there. We can do it by, what's the next way? Here we go. Extracting square roots. This only works on certain kinds of problems that don't have a middle term. Let me show you what I mean. This has 3 terms and it's a quadratic. But when they only have 2 terms, they don't have that middle term like this, then I can answer my questions with this extracting square roots thing. Would you please write that one down? So my answers are, what number can I get here so that it'll equal 0, right? I'm trying to get the x alone, so I'm going to go x squared, and I'm going to add 5 to both sides. I'm going to say x squared is equal to 5. Now from here, if it said extract the square roots, don't you think we might want to use a square root? So I'm going to square root both sides. Square root, and then x equals the square root of 5 is missing part of its answer. What did I forget to do? Plus or minus. All right. So x equals plus or minus root 5. All right, so I've got 2 answers. If I put in the square root of 5 right here in this x spot, it will make it work. And if I put in opposite of square root of 5, it'll also work, because when I square it, the negative will go away anyway. So there's 2 answers. I did it by extracting square roots. I want you to try this one. Is this a quadratic? Yes, it is. So you can solve it by extracting square roots. Why? Because it doesn't have a middle term. It doesn't have anything like 4x or 2x or anything like that. So write that one down and solve it. Your pencil's not moving? You can't possibly be doing what I asked you to. First thought is you're just trying to get x alone. This is not factoring. I didn't say solve by factoring. This is the one where you solve by using square roots. So first thing, get rid of the 4. 3x squared equals 8. Then get rid of the 3. Then I have x squared equals 8 thirds. How do I get rid of the x squared? Square root. X equals square root of 8 thirds. Plus or minus. Very good. It's okay if you have an answer that doesn't come out nice like that. But watch out. Sometimes they do and you don't think they do. Like sometimes you'll end up, like on today's homework, you'll end up with one that's kind of like this. And it's actually got a way simpler answer. Because what's the square root of 9? Over the square root of 16. So it's x equals plus or minus 3/4. See what I'm saying? Sometimes you can do the square roots. That other one had like square root of 8. I don't know what that is, so I have to leave it. Okay. So now, we've been talking about the different ways to do it. You can extract the square roots. You can complete the square. It's kind of slow and complicated, but it works. But that's not something we're going to focus on today. The last one is the quadratic formula. When all else fails, you can use the quadratic formula. That's the one that goes x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And I know you've heard that before, and I just saying it to you, so you should be able to write this thing down in your notes without me reminding you anymore. But try it, and then I'll write it on the board and make sure you get it right. Starts with x equals. Please write out that quadratic formula in your notes. It's huge because not all these problems can be solved with graphing. Not all of them can be factored. Not all of them can do square roots. But all of them, every single one of them, can be solved with a quadratic formula. So quadratics and the quadratic formula obviously go together. All right, if you did not have it memorized, you have to go home and memorize it now or you don't have a chance. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And seriously, that song is a really good way to memorize it, get it stuck in your head, and then from there it's pretty easy. X equals negative b. And I actually wish we used opposite b. You know why? Because sometimes when the problem is like this, kids will think that, oh, b's already negative. That's cool, so I can just put in 2. But that's not what you're supposed to do. You're supposed to put in a negative 2 here, and then you'll have a negative negative 2, which will be positive 2. So if we said opposite of b, then if b is negative 2, you could say, oh, just use the opposite of that, which is 2. All right? So I actually want you to try to take A and B and C and stick them all into that formula right there. And it may not work out nice, but I just want you to stick all the numbers in the right spots. Sometimes, again, you got to expect your answers aren't always going to come out to nice, clean answers in here. It's okay if it has a big, nasty square root. I'm going to take my b's and put little empty parentheses for them, because that's what a variable is like, is a little set of empty parentheses. And now I'm going to put in b, which was negative 2, into that empty parenthesis. Negative 2, negative 2. Now I'm going to do that with my 2 a's. There's an a here, there's an a there. I'll put an empty parenthesis, and I'm going to stick in my a, which is 3. And last is my c, which is 12. I'm going to put an empty parenthesis, and I'm going to put 12. Okay. So now I just have to multiply this whole puppy out. So you go negative negative 2 makes 2. Plus or minus the square root of 4 minus 12 times 12 is 144. What I did there? All over 6. And don't forget this is x equals, because I'm finding the x's, the x-intercepts. And now 2 plus or minus square root of negative 140 all over 6. Now from here, what rule am I breaking? Something wrong with this. Yes? Exactly. There's a negative under the root. Why is there a negative is a different question. I understand, and I'll get to that in a second. But the fact that there's a negative under the square root is a problem. You're not supposed to have that. That makes the only way to do this means that the answer must be imaginary. Okay, now, how did there get to be a negative there? Because I had a negative 4 times the 3 times the 12 made negative 144. That's why. Okay. So now, I've got my answer, and it's right here. If you tried to do it farther, your calculator wouldn't let you, because if you tried to type in what's the square root of negative 140, it probably said non-real answer on your calculator. It would if you tried it. Okay? And that means that your answer is not a real number, because you can't have negatives under the square root. But you remember the whole I thing? You can use that. Now, I'm probably going to teach that in my classes tomorrow, but I'm not going to mess with your head on that one today, because there's too many things to go over today. But in this case, for today, if you get a negative under a square root, it's like, cool, I'm done. You can just say no real answers. Okay? The answer is a non-real answer. It's an imaginary one. I'll give you the really short summary. When you have a square root that's negative, especially if it's negative and nice like this, let's say it was like this, then do you remember that the square root of 144 is 12? And then if it's a negative under there, you just change that, the answer, to be 12i. That's how you do it. And then you can simplify things and say, oh, there's a 2 in here. 2 goes in there once, 2 goes in here once, and 2 goes in here 6 times. 1 plus or minus 6i all over 1. And something over 1 really doesn't do anything, right? So I can just get rid of that divided by 1, and there would be my answer. That's an example of how to do the imaginaries. But for today, you can just say imaginary or not real. Okay? All right, moving on. So when you have a quadratic, you can solve it 4 different ways. The quadratic formula will always work. That big nasty x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And nobody's going to give you that formula. You have to have it memorized, but you can use it if you have it memorized. Okay? Completing the square we'll talk about at some future date. Extracting the square roots we already talked about. And don't forget, if you do a square root, you need to do a plus or minus on your answer. And the last one was the factoring. So let's see if you really absorbed all of that. And we also have to practice the graphing thing. All right. If you graph this on your graphing calculator, it's going to look something like this, and it's going to have 2 spots that it touches. And how do you find exactly where it touches? Well, you got to know what they're called, first of all. Those are called the roots, the intercepts, the zeros, and the solutions. There's 4 names for it. Only one of them appears on your calculator. But all 4 of those names are going to appear on your tests. If they ask you what are the solutions, you have to know it's the same exact thing as if I asked you the roots, which is the same exact thing as if I asked you the x-intercepts, which is the same exact thing as if I asked you the zeros. Okay? So would you please write those words down right now on your notes? Say these are the roots, x-intercepts, zeros, and the solutions. Those spots where it touches are the x-intercepts, the roots, the zeros, and solutions. Now, only one of those is on the calculator. So I'm going to have you actually type this into your calculator right now. Under your y equals screen, type in that. Remember the little power? It looks like this. 2x to the power of 2 minus 3x minus 2. If you don't have your graphing calculator here, I do have a couple you can borrow up in front, but please bring your own graphing calculators. You need them pretty much every day. It's okay. We're all going to have a day where you're out of batteries or whatever. And I'm out of calculators now, sorry. Okay. So, type this thing in. 2x squared minus 3x minus 2. And then hit graph. And if it doesn't show up, type zoom 6. Zoom 6 is a good zoom. It gets you the window that you probably want. All right. Now, no, I guess I have to do it this way. If we're going to do this graph, I'm going to have to, my software isn't working on my computer yet to show you exactly which buttons to push and stuff. That kind of sucks, but I'm trying to be patient with the tech department because they got a lot of stuff going on right now. So if I want to zero in on this point and I want to know exactly where it is, here's what you do. Everybody, find the second button, hit second, and then right above the trace button is the button that says calc, as in calculate. So you hit second, calculate. And we already hit second. All right, sorry about that. I was hoping somebody fixed theirs. All right, under the calculate menu, you have 4 choices. Does one of them look like one of the words I was just saying a second ago? Which of the 4 words is on that list? Yep. Be under the calculate menu, so I can calculate the 0. Underneath that, the first thing that you do once you hit that is it asks you to take the little spider thing and put it to the left of wherever you're trying to do. If I'm going to do this one here, I got to be to the left of this point, which in this case means underneath it. Okay, that'll be to the left of it. And then I hit enter. And then it wants something to the right. So you go to the right of the point you care about. And in this case, that's above it. But it's to the right of it. And then you hit enter. And the last thing says guess. And that means get close to where you think it is and then hit enter one more time. And it'll tell you the answer. Those of you that were following along with that should be able to tell me, what did it say? Okay, so 2. X equals 2. All right. Now do it on the other side. Do the same thing. Second, calculate the 0, and then get to the left of it, which is above it. But that doesn't matter. It's because it's to the left of the main spot here. You go to the left of it, then to the right of it, and then the last time you hit it, you get close to it, and it'll tell you the answer, and it's some decimal. I can't remember. Negative 0.5. So x equals negative 0.5 is one of them, and x equals 2 is one of them. There are my 2 answers. Should there be 2 answers? Yes, because it's got a degree of 2. All right, so that's how you do it with a graph. And let's say I had to solve this algebraically. 2x squared minus 3x minus 2. And remember, it equals 0. Why does it equal 0? Because we are looking for the x-intercepts. And the x-intercepts are where y is 0. I could have a y right here. But since I want the y to be 0, I put a 0 right there. So your equations should always be set equal to 0. And now, I must be able to do this some other way. Well, there's factoring it. Try factoring it. Because if it would factor. But I already know, because I already know what the answers are, that I'd have to have an answer that's 1/2. So maybe I can still make that work. All right, so I'm going to try 2x and x. And how do I make a 2? Because I got to get this answer at the end to be 2. So this and this have to be what and what? 2 and a 1. So I'm going to try a 2 and a 1. And then one of them has to be negative. I'll slap this one in as negative and this one's positive. And I try it and see if it works. That equaled 0. Didn't work. So now I'm going to try something else. 2 and 1 is what I try 1 and 2. And this time I'll make this one negative and this one positive. Outside's 4, inside's minus 1 makes positive 4x. Whenever you're really close, positive 3x. Whenever you're really close but you're the opposite of what you want, then you change the signs. Just the signs. Plus, minus. And now, when I do the outside, I get negative 4, inside positive 1, makes negative 3x. Just double check the firsts, make that, and the lasts, make that. Yes, I factored it right. And so now, that's factoring. Again, You don't know how to factor. Obviously, that'd be a big disadvantage right now. So you have two answers. 2x plus 1 has to equal 0, and this one right here has to equal 0. But that's really easy. I can do it in my head. X has to equal 2. There's one of my answers. And the other one's over here. 2x equals negative 1. X equals negative 1/2. And isn't that what we got on the graph? Yes. So I showed you algebraically, and I showed you with a graph. One of each. So you can do it with algebra. You can do it with a graph. Do you think if I would have used a quadratic formula, would it have worked too? Yes, that always works. Quadratic formula is probably the best way because you know it's going to work. The only bad part is it's complicated. So, all right. So if you were going to solve this graphically, the first thing you'd do is type it in your calculator. Then you'd graph it, and it would look kind of like this. But what's weird about this one is that it has a degree of 3, so it should have 3 answers, and yet it only touches once. That means there's one real answer and 2, what do you think, imaginary answers. The ones that touch are reals. The one, and then we know there's 2 others that we can't see. They're like leprechauns. You know they're there, but you can't see them. Right? So the imaginary ones, you can't just say, oh, there's the imaginary ones. No, they're not there. That's totally not that's not where it's touching, and so that's not it. You can't see the imaginary ones. I can only see the real ones. So I know it's got one real answer, and I'd use that second calculate. So you use second calc to find the zeros. Wait a minute. And that looks kind of like that, and you end up with the answer, which is right here, which would have been 1.32. And that's the real root. The other roots, the imaginary ones, you don't know what they are. Only the quadratic formula could tell you that. And what would tell you it was imaginary is that you're doing the quadratic formula and you get a negative under the root. That's how you know there's imaginary roots there. Okay, we're almost done. Last thing that you got to process is, what if you're solving it not a quadratic, but something that's kind of like a quadratic? Absolute values. They always have 2 answers too. I'm going to go back to one of the simplest quadratics. Would you agree that there's 2 things that would make this true? X could be 6 and x could be negative 6, right? Okay, there's 2 answers. Same idea. When you're solving these, you'll want one example of this in your notes. Would you please write this down in your notes? Absolute value of 2x minus 1 equals 6. I just rewrote the same exact thing I just saw. And that's what you do. The first of your 2 answers is the exact same thing you saw, except it doesn't have the absolute values. And the other answer is the exact same thing you saw, 2x minus 1 equals opposite of 6. See, because remember how if I could make this whole thing underneath here equal to a 6, obviously it would work, but it would also work if it equaled a negative 6. So now I just have to solve this equation, and I have to solve this equation. So I add 1 to both sides, I get 2x equals 7, and then I divide by 2 on both sides, x equals 7 over 2. And then this other side, I add 1 to both sides, 2x equals negative 5, and then I divide by 2 on both sides, and I get x equals negative 5 over 2. 2 answers. All right. So whenever you have an absolute value, you can divide it up into 2 equations. Yes? Okay. All right. Just so you can make sure you got it. If I had this, first I would write it exactly how I see it, 3x plus 1 equals 15. And then I would write it 3x plus 1 equals negative 15. Do you get what I'm saying there? And then I'd solve this one over here, subtract 1 from both sides, 3x equals 14, x equals 14 thirds. And over here, subtract 1 from both sides. 3x equals negative 16, and x equals negative 16 thirds. There's 1. There's 2. All right, so that's how you do absolute values. And then there's one more thing. You probably didn't know this, but it's going to come up to help you a million times this year. If you graph both sides of an equation, you graph this side, y equals that, and you graph this side, y equals that. And you see where the two lines cross, that's the answer. That'll work for any big equation, even just big, horrible. Okay, if I want this answer and I only had a graphing calculator, I would graph this side, y equals all that junk, and graph this side, y equals all that junk, and I would see where the two lines cross, because that's the answer. That works for any equation. Don't know if you knew that or not. You probably didn't. I didn't know that until I became a math teacher. All right, so you can graph to solve this one. I'll just do this one for you. If you type this puppy into your calculator, it would go ABS 2x minus 1. That's how you do absolute value. And then the other one is y equals 6. And then when you actually graph it, it looks like this. And the answers are the two spots where it crosses. Here. So this is one of them, and the other side's the other one. And you just use your second calculate menu, and one of the options is intersect. That's where the two lines cross. And it tells you the intersection point. So the intersection is what I wanted in this whole thing was an x. See, it's an x. So I want the x of it. So there's my answer, and there's my answer. So it goes negative 2.5 and 3.5. Okay, so moral of the story. Whenever you have something to solve, if you can graph both sides of it and see where it crosses, that is a graphical way to solve your problem. Now, on your tests, a lot of times there's a graphing test where this would be totally okay because the skill we're testing you on is graphing. But don't just say, well, heck, I never have to even solve an equation anymore. I'll just do this. Because if you are told to solve it algebraically, then this would not be allowed. You wouldn't be given credit for solving it with a graph if it says to solve it algebraically. So back to the kinds of problems, if we had this one, for instance, solve algebraically, that means I can't just go graph y equals this and y equals that. It would have worked, but I'm not allowed to. So to solve it algebraically, I divide by 3 on both sides. 3, and then this would cancel. I'd have 4x. Oh man, my brain's giving out. I'm almost done for the day. X minus 2 equals 5, and then I would split it up into the two equations. Notice I shouldn't split it up until I'm down to just an absolute value problem. And now I can split it up into the two equations. 4x minus 2 equals 5, and 4x minus 2 equals negative 5. All right. This one, last thing, this doesn't look like a quadratic, but it is. Because as soon as I start solving it, I'm going to start by squaring both sides. Why do I do that? Because I want to get rid of the square root. And the squaring gets rid of the square root, just like I wanted. And I'll have x plus 3 equals x squared. All of a sudden I got x squared, and now it is a quadratic. See what I mean? Didn't look like a quadratic, but now it is. And now I could solve it with the quadratic formula, with graphing, completing the square, which you don't know how to do, or factoring. Okay? The biggest ones, quadratic formula will always work. And factoring, we do a lot. We do a lot of problems where when you're on the test, a lot of times you can factor them. All right? Here is your homework. You have about 10, 12 minutes to work on it.